Okay, in this problem, if we know the limit of limit x tends to a plus f of x and limit x tends to a minus f of x at an interior point of the domain of f, do we know limit x tends to a f of x? Okay, so we know a plus and you know a minus. Approaching a from the right side, approaching a from the left side. Obviously, we know what exactly is the limit x tends to a. If both are equal, right? If both are equal, then obviously there is a limit. If they are not matching, then limit does not exist. Okay, fine. Now, um, if limit x tends to c exists, can you find its value by calculating x tends to c plus? Obviously, if it is exists, that means x tends to c plus should be equals to x tends to c minus, and that should be equal to the limit, right? So that's what he is also mentioning. If this is c plus, then c plus, and if it exists, that means both should be equal, and both should be equal to the same number, right? So that's why limit exists. Very good. Next, now f is an odd function. Okay. Now limit x tends to 0 plus f of x equals to 3. Does it tell anything about limit x tends to 0 minus? So what is an odd function? Odd function is f of minus x. We
Is
remember,
equal
no?
to
F
minus
of
f of
minus of f of x. Let's say for example, what should happen to f of, let's say 0.5. We are approaching 0 from the right hand side, right? F
Hmm.
of 0.5 is some number. F of minus 0.5 should be minus of that number, right? So for example, limit x tends to 0 plus. That means when x is close to 0, f of x is actually equal to 3. So um, if you plot the graph like this, f of 0.1 something, it should look something like this. This value is, let's say, 3. Okay, when you are approaching 0 from the right hand side, you are approaching 3. That's what this means, right? But we also know that because it is an odd function, okay, whatever this value, if let's say whatever f of point 0.5 is, let's say whatever, some 4 or 5, f of minus point 0.5 would be minus 4 or minus 5. Or in fact, what we have discussed, odd function means if you rotate the graph 180 degrees, you'll still get the same graph. Agreed. If you rotate it. So basically, this graph would look something like this. If you are approaching 3, obviously from the negative side, you should approach minus 3. Right? So, you should approach minus 3 if you are approaching from the opposite side. 45. So that's what he is saying. Okay? If you are approaching plus 3 and if it is an odd function, then what does that mean? That means you are approaching negative 3 when you are approaching from the other side. Okay. Now, this time f is an even function. Okay. If it is an even function and limit x tends to 2 minus is 7. That means we are approaching 2 from the left hand side, you are reaching 7. Okay. Now, can we tell anything about when you are approaching uh, minus 2 again from the left or minus 2 from the right? Okay. So what is an even function? Even function is something
is
f
equal
of
to
minus x equals to f of plus x. Okay.
yes.
So let's say this point is 7 and this point is 2. Okay. Yeah. What does this mean? X tends to 2 minus. So we are approaching 7. Something like this. Okay. Now what does this mean? Even function is symmetric about
Exactly.
y-axis, right? So then, if this is symmetric, we should look something like this at minus 2, right?
Hmm.
Okay, so the other side of it, it could be something like this, something like this. We don't know what exactly is this. When right side of 2, we know we are given only about left side of 2, right? Now, what does that mean? We know only the right side of minus 2. We don't know about left side of minus 2. Okay, left side of minus 2 means right side of plus 2 because it is an even function, right? So we are approaching 2 from the negative side. We are getting 7. What does that mean? If we approach -2 from the positive side, we will get 7. Right? Negative side, we don't know. Negative side, we cannot comment. We can comment only when we get positive side of 2. Right? Okay, so that's what he is saying here. Okay. Negative positive from positive side of -2, we can say it is 7. Negative side of -2, we cannot say anything because we don't know what is the positive side of +2. Right? Agreed, no?
Yes, sir.
Okay, cool. Limit x tends to 0 minus x by mod x. Is it -1? If so, why is it -1? Are you convinced?
Mod x is step function.
Hmm. Mod x by mod x. When x tends to 0 minus. That means x is a negative number, right?
Hmm.
So whatever slightly lesser than 0, but still x is a negative number. If x is a negative number, what will become mod x?
Positive.
It is positive, but is it x or is it minus x? What is mod x when x is less than 0?
Minus.
Minus x, right? So this x and that minus x will get cancelled. We will be left with -1. Agreed? Okay. When x greater than 0, then what is x by mod x? What is the limit?
1.
That should be 1. So does limit exist? X tends to 0.
Hmm.
Does limit
No,
exist?
it does not.
It does not. One side it is -1,
Minus.
and the other side
One
it
side.
is
+1.
+1. So limit does not exist. Okay. Okay. This one, x tends to 2 plus. Okay. That means x is approaching 2 from the right side, x is greater than 2. So obviously this one should be positive, right? So x minus 2 by the same number, which is equal to 1. If you approach from 2 minus, if
Then
you
it will
approach
be
2
negative.
minus, then that will be -1. Okay. Now f of x equals to x squared times of sine 1 by x. We did this using sandwich theorem. Sine 1 by x is a number that lies between +1 and -1. Okay. And this x square into sine 1 by x should always be lesser than or should always be lying between -x square and +x square. Right. So that's why the limit, that's how we discussed about the limit of this. Okay. Now, okay, coming to a continuous function. Okay. See, continuous function means the limit should exist. Okay. So basically the function should approach a certain number and the value of the function should also be the same number. Okay. Earlier, we are not worried about what is the value of the function. Okay. So we're worried about what the function is approaching to say what is limit. Now, when we talk about whether the function is continuous, when it is continuous, when the value of the function is also approaching where the function is also equal to where the function is approaching. So there it is continuous. Basically, in normal terms, continuous means you don't see these breaks. What are these holes also we don't see. Okay, limit means holes are fine. Okay, but continuous means holes are also not fine. Okay, it should be absolutely continuous. You don't need to lift your pencil or pen to draw the function. Okay, here you need to lift your pen and put a dot, right? So this obviously this is not continuous at 2, at 1, at 4. This is not continuous. Agreed? Because it is actually you have to lift your pen at least at these 3 points, right? So that is the basics about continuous. Okay, let's see the technical definition. F of x is continuous at an interior point C of its domain. We talk about interior points only. Exterior points anyway we don't care. domain. When limit extends to C, f of x equals to C. What that means? Right side if you approach, left side you approach, the function should approach a common value. At the same time, the value of the function is also that value. Okay. Whenever it is not continuous, we say it is discontinuous. Okay. So for example, this kind of function, it is always continuous. Okay. This function, step x or something, it is discontinuous at this thing. Okay. So and it's what about this?
Discontinue.
At all integers.
Yes.
1, 2, 3, 4, at all integers, it is discontinuous. Okay. Now, see this one continuous, discontinuous here, discontinuous here, discontinuous here. Okay. When these discontinuities are because of these holes, we call it removable discontinuity. Okay, because if you put that single number here, it will become continuous. Okay, so what about this one?
Discontinue.
This is discontinuous. Okay, why? Because both are approaching infinities, but infinity is not a number. This is discontinuous because we don't know what exactly is this. Okay, firstly, the limit should exist. Here, the limit itself doesn't exist. Limit should exist, value of function should exist, and both should match. Here, value of function doesn't exist. Right? Limit both sides are plus infinities, but value of the function doesn't match, and limit also. So this one value of function is not even defined at zero. Right? 1/0 is not defined. Okay.
Then, if at one point, if it is discontinuous in the entire graph, then it is deemed to be discontinuous itself.
It is deemed to be discontinuous, or otherwise, if you restrict the place, then you say it is continuous between these points. Okay. So most functions, what we say when we restrict, it becomes continuous. Okay. So for example, this function only. If you instead of call, if you call the domain as zero open bracket to infinity, then this becomes continuous. The only point is zero, right? That is the only problem. So generally, what we do, we restrict those things. Okay, we know when there are only particular points. For example, tan x. Tan x we know at pi by 2 it is discontinuous. But we say open bracket minus pi by 2 it is continuous. Okay, so that's the importance of this to understand how the functions behave and doing the domains accordingly. See, for example, this one. Okay, so it is not continuous at zero, but we don't include that also in domain. We say the domain is minus infinity to plus infinity except zero. Okay, so that's how we call it continuous. Okay, okay. So generally, every straight line is continuous. Agreed. Every parabola is continuous. Agreed. Okay. Similarly, every cubic equation, every equation which is of power 4 or whatever, in fact, every polynomial is a continuous function. Okay. Like just like every straight line is continuous, every parabola is continuous. Higher orders are also continuous. Okay. P function by function. Okay. Polynomial, we'll call it a rational function. Numerator is one polynomial, denominator is another polynomial. Okay, this need not be continuous because q of x can become 0. Okay, the points of this discontinuity is whenever the denominator is actually equal to 0. Okay, ma? Okay, so, and if a function is continuous, we discussed, right? Inverse of a function is actually a reflection of the graph with respect to y equals to 1, or you flip the paper, etc., to get the 1. So, obviously, if that original function is continuous, and if it has an inverse, the inverse also will be continuous. Okay, now composite of the function. If one function is true functions are continuous, then if this is continuous, g is continuous, g of f is also continuous. Okay, simple. Okay, this is actually square root of some parabola. Okay, obviously it is continuous. X power 4 plus 1 will never be equal to 0. Right. So that's why numerator is continuous, denominator is continuous, there are no zeros. Okay. And what about this one? Why is this continuous? At x minus 2, this becomes not defined. But x minus 2 is not there in the domain. X equals to 2 is not there in the domain. Okay? Continuous, sorry, x equals to plus or minus root 2. X equals to C. X equals to plus or minus root 2 is not there in the domain because whenever denominator is 0, so it will not be there, right? So that's why because we have domain that is not even considered, it is continuous in the domain. Okay? In the respective domain. X square plus 2, it will never be equal to 0. Okay? Okay. These things you can do, right? Limit of uh, some function of, basically it's a composite function. What we do is send the limit inside. Okay? And try to evaluate that one. Sin x by x, the graph you remember, right? Sin x by graph, to remove the discontinuity, what we do, we define it, we define that f of sin x by x equals to 1 to make it continuous, if you want to include that in the domain. So we want to extend this at x equals to 2. So for example, this one definitely at x equals to 2, the denominator is becoming 0. Right. But if you write it as factors, this function is actually equal to x plus 3 by x plus 2. Right. So the limit exists basically. What you are trying to say, for this function, the limit exists. What is the limit? Limit actually equal to 5 by 4. So that's why to remove the discontinuity, continuous extension, what you do, you put that 5 by 4 here. Basically, f of 2 is 5 by 4, 5 by 4. If you put that, then this discontinuity is actually removed. Okay, ma? Okay, so now this is very intuitive, okay, but very important. Intermediate value theorem. What is intermediate value theorem? There is f of a, there is f of b. Okay, and if the function is continuous. If the function is continuous on the closed interval a comma b, not open interval. What does that mean? For every y naught, okay, if y naught is any value between f of a and f of b, for every y naught, there must be some c. Okay, so basically what it is saying, f of a is let's say 2, f of b is let's say 4, and if the function is continuous, then for every number between 2 and 4, there must be some x between a and b. Agreed? It's normal only, right? Y between a and b, y between y not should be between f of a and f of b, why it should be between 2 and 4, why not below 2 or above 4?
Because it
Because
is constricted to that part.
no. So we don't know what is the nature of the function. The function can be like this. We just know it is continuous. Okay. We just know it is continuous. The graph could look something like this. It could look something like this. It could be anything. Okay. Whichever way it is, we are definitely ensured that the graph should cover this part of the distance between this and this. So in the worst case also, the graph should go something like this, or in fact even a straight line like this. It has to cover this part of the distance. Okay, it could cover something higher, something lower, but definitely it has to cover this part of the distance. Okay, so that's why if you take any number between these two, there must be definitely some number between a and b. Okay,
Above
that's
that or below that, you won't get a value.
you don't we are not certain below that. So for
Mm.
example, if you are taking a number below this, the graph could go something like this. We don't know, we are not certain. Okay, but as long as the number is between this, we are definitely sure that there must be some value at which the value of the function is actually equal to this y naught. Okay, that is intermediate value theorem. Here something important, why this is close bracket, why not open bracket, right? Why it is there is a close bracket here. That means f of a should be defined, f of b should be defined. Why close bracket? Okay, let's take another example. Okay, 1 by x, it looks like this, right? If you take open bracket, okay, if you take open bracket means what? F of 0 is infinity. Okay, f of 0 is infinity if you take this kind of function. Okay, f of 0 is infinity, and let's say f of 10 or f of 1 is something. F of 1 is 1, let's say. Okay. Now that doesn't clearly work out here. Agreed? Okay. That doesn't clearly work out here because f of infinity is not a proper number, and if it is not continuous, we don't know. Okay. We don't know what exactly, whether that lies between this and this or not, we don't clearly know. So that's why we say we always put this closed bracket. Understood? Why we are saying it should lie between this and this range?
It should
Why?
always be a finite value.
It should always be a finite value. Okay, this A and this B, it should be closed, and at the same time f of A and f of B. Okay, f of A and f of B, if f is continuous and closed interval A, B and B, and f of A and f of B is there, then then we can say this. Okay, it doesn't work for something like this. Okay, it will work if it is between zero point 0.5 and 1. Okay, because zero point 0.5, it's a finite value again. 0.7 and zero point 0.1, 0.01, whatever. But from between 0 and 1, it doesn't work. Understood? It can work for anything else. Okay, slightly greater than 0. If you fix that number, we know what is f of, let's say, zero point 0.01 and what is f of 1. So then it will still work. Okay, if it is, but once you say 0, then we cannot be sure. Okay, or uh, or some cases you'll get functions like this also. Right, let's say this one only. Okay, f of 1 is infinity or minus infinity, we don't know. Okay, and between, let's say this is 2, this is defined, this is fine. Okay, f of 1 is plus infinity or minus infinity, we cannot clearly say. Now how do you define this? Okay, the what should be the value lying between? We cannot tell, right?
We cannot tell.
We cannot tell. Is it minus 1? Is it plus 1? What exactly is this? We cannot tell, right? F of A we cannot tell, f of B we cannot tell. So how do you define? Why not? Okay, that's it, to avoid this confusion. What instead we choose some functions that are at least clean in the region that we are talking about. Okay, ma?
Yes, sir.
Okay, very good. Um, okay, is it continuous at x equals to 2?
So no.
No, because there's a hole here. What about this? Is it continuous at x equal to 2?
Yes.
This one always continuous.
Yes, sir.
This one not continuous at 1.
No.
It is not continuous at 1, no?
No, sir.
Okay, right. Okay, now this is graphical way of looking at things. Now, how do you define algebraic way? How do you see it? Okay, so what we do, this function is a polynomial. This is a straight line. This is a constant function. This is a straight line. This is a constant. So individually all are continuous. Okay, individually all are continuous. In this case, what we do, if the overall function has to be continuous, if there are breaks, then the break should happen either at 0 or at 1 or at 2. That's it, right? Individually all are continuous because this is a parabola, this is a straight line, this is a constant, this is a straight line, this again is a constant. So what we do, what is this function approaching when you approach 0 from the left hand side? Okay, 0 minus 1. Okay, we directly substitute 0 here. Limit extends to 0 minus of this one. Okay, so then what will this become? This becomes minus 1. If you approach 0 from the right hand side, what you will get? You are getting 0. So obviously there is a break here. Understood?
Yes.
Okay, if you plot the graph of x square minus 1, okay, just write this function x square minus 1, 2x, 1 minus, I think it is already graphed. See here,
Hmm.
x square minus 1. Okay, what is the function? X square is something like this. X square minus 1 is 1 unit shifted downwards. This is this one. Okay, x square minus 1. Okay, now when you approach x, when you approach 0 from the left hand side, what is it? 0 minus 1. That is this one, minus 1. This function is approaching minus 1. Okay? Left hand limit of 0.
Sir, if you take individually also, aren't they discontinuous?
They are discontinuous. If you look at the graph also, they are discontinuous. Individually, if you do it algebraically also, that is also discontinuous. Okay?
I thought you said continuous. That's why I
No,
was
no, no.
confused.
It is discontinuous only. Okay? At 0, it is discontinuous. Okay? 0 minus 1, we are getting minus 1. Okay? Uh, right. If you are approaching 0 from the right hand side, what you are getting 0. Right? Value of the function is not defined. Okay? F
Hmm.
of 0 is not defined. We know f of 0 minus, we know f of 0 plus. Okay? And at x equals to 1, it is actually equal to 1. That single dot. Okay?
So
Okay,
is it
left.
continuous or still discontinuous,
It is
sir?
discontinuous, no?
Yes, sir.
Continuous means left hand limit, right hand limit, and the value both should match. Here, left hand it is approaching 2 times of 1, it is approaching 2. Right hand it is approaching 4 minus 2 times of 1, that is also approaching 2.
Hmm.
But the value of function at 1 is not equal to 2.
Hmm.
Okay, so that's what is discontinuous at 1. And f of 2, it's not even defined, right? Less than 2 we know, greater than 2 we know. Limit exists, but value of function doesn't exist. Okay, ma?
Yes.
Okay. Um, these all questions you can answer. Okay. Where the continuity breaks here when x equals to 2, when
Hmm.
the function is not even defined. X equals to minus 2, it will break, right?
Yes, sir.
If you factorize this, probably you will find something. Here
Hmm.
also, if you factorize this, you will find something.
Hmm.
Okay. So this one, when you just need to check if this is always continuous. X minus 1 is also always continuous, but mod of x minus 1, it can break when x equals to 1, right?
Yes.
So what you have to do, x it tends approaching 1 from left hand side, you will check once. Approaching 1 from right hand side, you will check once. And that's how you will say whether it is continuous or not. Okay?
Hmm.
Understood, no?
Yes, sir.
Okay. See, so he's saying it is always continuous. Okay, mod of x minus 1 plus sin x. It is always continuous. When I approach x 1 from the left hand side, let's say point 0.9, point 0.9 minus 1, it's actually equal to plus point 0.1, whatever. So this becomes sin x plus point 0.1. Okay, and when I approach from the right hand side, 1.1 minus 1, then also sin x plus point 0.1. Okay, it's actually continuous. What about this one? This is
This
always continuous. 1 by mod x plus 1. Okay,
that
this is
will be
also actually
discontinuous at
continuous.
minus one.
Okay, what more?
Will that be discontinuous at minus one, like when x is minus one?
Just try it, no? You are approaching, just try it.
Yeah, I'll go get a pen.
Ah, just try it. When you say
Whereby 2 is always continuous.
18 is always continuous,
Hmm.
okay? 1 plus mod x, okay, forget about 1 by this thing. If you just look at 1 plus mod x, okay? 1 plus mod x is always continuous, right?
Hmm.
Okay, so for example, what is mod x? What is x? X is this. Mod x means all the bottom part will come to the top. This is mod x. Okay, agreed.
Yes, sir.
Okay, what is 1 plus mod x? For this function, you are adding 1 at all places. That is this, right?
Hmm.
1 plus mod x. This is always continuous, no?
Yes.
Okay, so 1 plus mod x is continuous. X squared by 2 is continuous. So composite of that function or adding of two continuous functions is always continuous. Okay, ma?
Yes.
Cos x by x.
1. Continuous.
Is it continuous? If at all
No.
that's the
Cos
problem,
x
where is
by
the
x
problem?
is 0, no, sir.
At x equals to 0, what will happen? At x
1.
equals to 0?
It will become 1.
No, no, why it will become 1? It is not defined. No, see, continuous means it's not just about limit, it is about
The value which it
value
holds.
also. At
Hmm.
0, what is the value? 0, cos 0 by 0, which is 1 by 0, we don't know.
We don't know. So
We don't,
discontinuous. Okay.
we don't know. This is discontinuous, right?
Hmm.
Okay, and can you imagine the graph of cos 0 by 0? Okay, how cos x by x, how does it look? Okay, I'll show you the graph also. One second. Can you see my screen, mark?
Yes, sir.
Cos x by x. See what is happening?
Breaking at 0.
Breaking at 0. Why is it breaking at 0? Because cos x, whether it is cos zero point 0.1 or cos minus zero point 0.1, cos x is an even function. Okay. Okay. Cos zero point 0.1 and cos minus zero point 0.1 are still the same. Okay.
Yes.
Agreed. So, but cos zero point 0.1 by zero point 0.1, this is a positive value. Cos minus zero point 0.1 by minus zero point 0.1, because the numerator is positive, denominator is negative, it becomes a negative value. Okay. So basically what we are saying, cos x by x, this is an odd function. Agreed?
Yes, sir.
Because cos of minus x by minus x is minus cos x by x. Right?
Hmm.
This is an
Yes.
odd function. This is an odd function, and this should not break only when both are tending to 0. Otherwise it will be a break. Right?
Hmm.
Odd function is continuous when both are coming to 0 only. Here it is not coming to 0. So obviously there is no way of they being same at f of 0. Okay, ma?
Yes.
Okay, if an odd function has to be continuous, then it has to approach 0 first. Okay, and the value of the function should also be 0. Then only it will be this. Okay, understood, no?
Yes.
Coming back to our original sheet. Uh, So x plus 2 by cos x. The function is not defined at multiple places, right?
Hmm.
Okay, whenever cos x becomes 0, this becomes this becomes not defined, right? So those are the places it is not continuous. Agreed? That's
Hmm.
what he's saying, right? Agreed, Mark.
Yes, sir.
Okay. So similarly, okay, similarly, these all things you can do. Okay, where it
Yes, sir.
is continuous, where it is discontinuous. Okay. Now these things also you can similarly do. Okay, x tends to pi. Whenever in denominator there is a thing, then that's a problem. As
Hmm.
long as it is not there, then it is not a problem.
Hmm.
Okay. So this one, if you have to extend this at continuity, basically this becomes x plus 3. So if you made z of 3 as 6, then this becomes continuous because there is a single hole. Okay. Whenever there are holes, you just fill the hole. Okay.
Hmm.
And whenever you are given these functions, we just need to ensure that at x equals to 3, this value should be equal to this value. Both limits should exist. So 3 square minus 1, which should be equals to 8, should be equals to 2a into 3. 2 times 6 into a. So a becomes whatever, 8 by 6 or something.
Hmm.
Okay. Similarly, you can define b to make it continuous. Basically, this value and this value should be equal to the same value at x equals to minus 2. Similarly, this and this should be equal to same value. Basically, this should be equal to 12 at x equals to 2. Okay, that's how you define x to make it continuous. Basically, this should be equal to this one at x equals to 0.
Zero.
Okay. Basically, what does that mean? Minus b by b plus 1 should be equals to b. If you just solve it, you will get what is the value of b. Okay, these kind of things are like that. So this one also same thing. Minus 1 you equate and then plus 1 you equate. This one, these two should be equal, these two should be equal. Okay, now something interesting here. Sin x by mod x. Do you think this will be continuous?
It will. Um. So we can't
Sin x
say.
by x we know. Okay, sin x by x there's a hole. We remember that. Okay,
Mm.
let's look at the graphs. Let me just project it. Okay,
Sin x by x is 1, so it is continuous.
sin x by x the limit is 1. Okay, there's a difference. Sin x
Okay.
by x at 0 it is not defined, but we just we agreed that it approaches 1. Okay,
Mm.
sin x by x. Okay, at 0 it is definitely not defined because something by 0. Okay, but it approaches 1, that's what we have said. So the limit is actually equal to 1. Okay, there's a hole here, but the limit is actually equal to 1. Okay, now there is sin x, there is sin x, and there is x. Okay, so because the values are sin x and x, the values they come closer. Okay, when it is zero point 0.1, this is also zero point 0.1. When it is minus zero point 0.1, this is also minus zero point 0.1. So that's why the ratio is actually becoming 1. Agreed?
Yes.
Okay, and obviously when x is positive, x is greater than sin x. Okay, when x is negative, x is lesser than this thing,
Sin x.
sin x. Okay.
Yes, sir.
Okay, so now sin x by x. Okay, because both are positive together or both are negative together, that's why both values are becoming 1. Now, if we take mod x, okay, mod x, sin x by mod x, I will draw the graph, you should explain what exactly is happening. Okay, uh, this is what this is happening. So now, can you explain what exactly is this happening? Why exactly is it breaking?
Because of the step function involvement, like.
Because of the mod function. So earlier you are doing negative by negative, but once you do this thing step function, step of x means you are doing this value by this value. Okay, you are forcibly making it negative here. Agreed?
Yes, sir.
Okay, earlier it is positive by positive, so that is this way it is 1. Here everything is same except that you are making it negative by negative, negative by positive. Okay.
Yes, sir.
So what exactly that means is this actually is an even function. Agreed? Sin x by x, sin minus x by minus x is actually equal to sin x by x. So that is symmetric with respect to y-axis. Okay?
Okay.
Okay. Agreed, no? Sin
Yes,
x
sir.
by x. It is symmetric with respect to this thing. But here what is happening? This is, if you flip the graph, it is still the same. So basically what you are doing, this you are making it an odd function.
Mm.
Okay, when it is an odd function, obviously if it is not approaching 0, it becomes discontinuous, right?
Yes.
Okay, that's what that is happening here. When you include a mod x, then this breaks. Okay, when you include a mod here also, then it's not a problem. Understood?
Okay.
Okay, include a mod here also, then everywhere you are removing the negative parts. Then it is not a problem. But if you include mod at only one place, then it breaks. Okay,
Mm.
whether you include in the numerator or let's say this you make normal x. Then also the same problem, right?
Yes, sir.
Okay, then also the same problem. Now coming back to our original sheet.
So, sir, can we say that if in a given value,
Hmm.
If the function is there, it means that entire thing is discontinuous itself.
What, man?
If in a given value step function is there,
Huh,
then we
huh.
can just tell that it is discontinuous
Uh,
directly.
no. So you have to be careful. You have to look at certain points only. Say
Okay,
function is discontinuous. Generally, at a particular point, it becomes discontinuous. Mostly, you will be asked in exam what are the points of discontinuity.
okay. They
Okay,
won't
most
ask whether it is just discontinuous or continuous.
generally
Same.
it is not asked, but if it is just discontinuous, then that is even easier. No, we can directly say it is discontinuous.
Yes, sir.
Okay, but generally you are asked how many points of discontinuity, whether it is discontinuous at x equals to 1, 0 or whatsoever. There you
Mm,
have to be very careful. Okay, when
mm,
the function is defined from R to R, then those points will become discontinuous. If your function is defined with including open brackets, right, then it is
mm.
still continuous. Okay.
Okay, sir.
Okay, if it is the function is defined in the domain, if the function, the mapping is defined from R to R, then these all will become discontinuous. Okay,
Okay,
but if you restrict that mapping, then they can be treated as continuous. Okay,
okay.
okay. Now, 10 power x minus 1 by x. Okay, and 10 power mod x minus 1 by x, and 1 plus 2x power 1 by x. Okay, these are interesting functions. Okay, let us go back again to our, okay, something interesting. 1 plus x, 1 plus x whole power 1 by x. Okay, this you would have seen. This the limit you would have seen, right? Limit x tends to 0, 1 plus x whole power 1 by x. This is actually equal to e. You would have seen this limit, the direct formula,
Yes, sir.
right? You would have, so what exactly are they talking about? First of all, there is a hole here. Okay, because 1 by x is 1 by 0 is infinity. Okay, this is actually an indeterminate form. 1 plus something close to 0, that is 1 plus 0 power infinity. 1 power infinity, right? Roughly speaking, right? When x
Yes, sir.
tends to 0, what does this mean? 1 plus 0 power infinity, that is 1 power infinity. Agreed?
Yes.
So it is an indeterminate form, but by doing calculation or by using other proofs, we can say that's actually this limit of this thing when x tends to 0 is actually this number e, which is something some 2.7 or something. Okay,
Mm.
understood? Okay,
Yes.
so there are different proofs. Let's not worry about the proofs right now. Let's worry about what exactly is the this graph. Okay, let's worry about that. This limit exists. Okay, limit exists for this function. Okay, though it is 1 power infinity, the limit exists, and what is the value of the limit? It's actually equal to e. Okay,
Okay.
now what is the question? 1 plus 2x whole power 1 by 2. So you would have seen these functions. Okay, now I'll do one thing. 1 plus 2x, I'll do whole power 1 by 2x. What will happen? It is still the same value. Okay,
Yes, sir.
okay, when this changes, it is still the same value. Okay, now if I make it 3 and 3, both threes, what should happen?
It will still be the same.
It is still the same value. Forget about this one, but still, this at x tends to z, it's still the same value. Okay, ma?
Mm.
Okay, so basically, this is also in that form. When sine theta by theta, when theta tends to 0, it's actually equal to 1. Similarly, 1 plus x whole power 1 by x, when that x, okay, when this part, whatever, tends to 0, then the value is actually equal to 2.
E.
Oh, sorry, equal to 1. Okay, now in this case, 1 plus 2x whole power 1 by x. How do we use this knowledge to convert that? Okay, here it's given 1 plus 2x, okay, whole power 1 by x. Okay, the value has suddenly shifted upwards. Okay, some 7 point something, that's what we are getting. Okay, so now this entire function, Okay, this 1 by x is there, no? This we can write it as 2 by 2x, right? 1 by x, we can write it as 2 by 2x. Agreed?
Yes, sir.
Okay, so this is nothing but 1 plus 2x whole power 1 by 2x whole of this power 2. Agreed?
Yes,
Agreed? So this means, basically what does that mean? That is in the form of 1 plus y whole power 1 by y whole square. Agreed?
yes, sir.
Okay, so 1 plus y whole power 1 by y. When y tends to 0 is what? E. So this value should be equal to e square. Agreed?
Yes, sir.
2.7 square. What is 2.7 square?
7.7.
7 point something. 2.5 square is how much? 6.25. Right? 2.7 square, some this thing. So basically, what is this becoming? This is becoming e square. Agreed, ma?
Yes, sir.
Okay. So now what is the question? Okay. We're asked to plot the graph. Can it have a continuous extension? Yes, it can have a continuous extension. Right?
Yes,
What is the continuous extension? E square. Okay. Now, okay, let's try to draw the graph of this one. 10 power x minus 1 by x. Okay. You remember this function, no? 1 plus
yes.
x whole power 1 by x is equal to 2.
E.
Equal to, sorry, e. When x
Yes.
tends to 0. Okay. Now, I'll do a similar graph. Okay. 1 plus 1 by x whole power x. Okay. So, here see 1 by x, and now this function limit extends to infinity. Okay.
Mm.
if
Yes,
we
sir.
if we if we do this function versus 1 plus uh, 1 plus y or 1 plus t whole power 1 by t, sorry, okay, I'll rather use x only. 1 plus x, earlier what was this? Whole power 1 by x. Okay, this is approaching 2.7 is what we have discussed, this function g. Okay,
Yes.
now limit extends to 0. Okay. Now in this, if limit extends to infinity, 1 by x will tend to 0, right? And x tends to
Infinity.
0, right? Okay.
Yes.
So understood. This and this are they are actually same. When x is 0 here, it means x is infinity here. Basically what I am trying to say, limit extends to infinity of f is also equal to limit extends to 0 of g. Agreed or not? Are you convinced?
Yes.
Okay, so basically what we are doing, when x tends to infinity, 1 by x tends to 0, that is this. Okay, limit x tends to infinity here is nothing but limit x tends to 0 here. These functions are actually the same. Understood?
Yes.
X tends to infinity, 1 by x tends to 0, and x tends to infinity, which is nothing but this 1 plus 0 whole power infinity. Okay, this is also 1 plus 0 whole power infinity. Okay,
Okay, sir.
they are similar, there are other differences, but let's not worry about other differences. Okay, so there is a relation between these two functions. That's what I am trying to say. Okay, now, now can you observe one thing? Here, when x tends to infinity, we are approaching the same number. Understood?
Mm.
When x tends to infinity, we are approaching this number only, 2.7. Whether you're approaching minus infinity or plus infinity. Okay, ma?
Okay. But
Okay.
can't we say that it is discontinuous? Only the 1 plus 1 by x whole per x graph.
Oh no, no, it is discontinuous. Okay, it is
But
discontinuous.
from
It is
that
no,
certain
no,
2 points, it is continuous.
no, no, no. We are not talking about continuity. I'm discussing this to for limits. Okay,
Okay.
limit extends to infinity. This function is actually equal to e. Limit extends to 0. This function is actually equal to e. That is the point here. Okay,
Okay, sir.
okay, ma. So this one. Okay, now x becomes 0. This function is not even defined, right?
Mm.
1 plus 0 power 1. Okay, when x tends to 0, what will this become? 1 plus 1 by 0, right?
Yes, sir.
That is infinity power 0.
0.
Okay, this function is not even defined. Okay, so there is no question of continuity. Continuity means the function should be defined and that value should be equal to the limit. Okay,
Yes.
okay. So, but this is important for limits. Okay, that's why we are discussing this. Okay, 1 plus x whole power 1 by x is actually equal to e when limit x tends to 0. Similarly, when x tends to infinity, 1 plus 1 by x whole power x should be equal to e. Okay, ma?
Fine, sir.
Okay. Now, coming back to our question. What is our question? 10 power x minus 1 by x. Okay. 10 power x minus 1 whole by x. Okay. So, looks like there is at x equals to 0, there is a hole definitely.
Yes.
Okay, there's a hole, but the function is looking like looking smooth otherwise. Okay, so it looks like we can actually fill the hole. But the limit exists. It looks like, right?
Yes.
Limit exists. How do you find the value of limit?
So,
How do you find the value of limit in this case?
let's see where the hole is
10
made and then
10
approach.
power x by x. We cannot directly substitute. Okay, we cannot do much algebraic manipulation also.
Mm.
Okay, we cannot actually remove a common factor here. So that's in these cases you do the LH rule. Okay,
Okay.
you differentiate numerator and denominator. If you differentiate once, denominator will become 1. There's no problem with this thing, right?
Yes, sir.
If you differentiate numerator, what will happen?
It will become x power, I mean, x into 10 whole power x minus 1.
No, 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 no. So that will work for polynomials. X power n it will work. Okay,
Okay.
when you have x in the power it won't work. Okay, it is called logarithmic differentiation. Okay.
Okay.
Okay, write it like this: y equal to 10 power x minus 1.
Mm. Okay, sir.
Okay, so dy by dx is d by dx of 10 power x minus d by dx of 1. Agreed?
Yes, sir.
Okay, this part is anyway we are not worried. So if you can do d by dx of 10 power x, it is done, right?
Yes, sir.
Now write y equals to d by dx of 10 power x. Okay, y
Mm.
equal to 10 power x, right?
Yes, sir.
If you take logarithms on both sides, what will happen? Ln y equals to x ln 10. Agreed?
Yes, sir.
Okay. Now, if you differentiate on both sides, what will happen? Ln y, if you differentiate 1 by y,
Mm. So,
y dash. 1 by y dash equals to ln
x.
10. ln 10. Agreed?
Yes, sir.
1 by y dash equals to ln 10. What is y dash? Y into ln 10. What is y? 10 power x.
Yes.
Okay. So, basically dy by dx equals to 10 power x ln 10. Agreed?
Yes, sir.
Okay. That's how we differentiate these kind of functions. Okay.
Okay.
Okay. Basically d by dx of a power x is a power x ln a. So, 10
Okay.
power x ln 10. Okay, if you differentiate this 10 power x ln 10 by 1. Okay, now if we substitute 0, 10 power x is 10 power 0 is 1 ln 10. So this value is actually equal to natural logarithm 10, which is 2.3 something. Understood?
Okay.
Okay, that's how we differentiate logarithm functions or exponential functions. Okay, so for
Yes.
example d by dx of e power x is what?
D by dx of e power x.
Ah,
E power x, sir.
why is it not x e power x minus 1?
It
It is
will
not x.
still fall under the same value.
No, it is not x e power x minus 1, no? E
No,
power
it's
x. Okay. E power x is e power x.
yes.
Similarly, 10 power x, we cannot say it as x into 10 power x minus 1.
Okay.
Okay. Okay. X power 3, x power 4, x power 2 by 3, these all cases, you can tell that. But for e power x, you don't tell that. Why?
So it's like not defined properly.
That's a different function, different kind of function. Okay.
Mm.
E power x is a different kind of function versus x power 10, x power 20. E power x is an exponential function. Right,
Okay.
because x is there in the power. Okay, whereas x cube, x power 10, x power 2 by 3, these are x is not in the power. X is at
Okay.
the base. Okay, these are all kind of polynomial functions. That is kind of exponential function. So you cannot differentiate exponential function in the same way as polynomial function. Now
Understood.
similarly, 10 power x is related more to e power x than x cube. Understood? Then x power 10. 10 power x is closer to e power x than x power 10. X power 10 is a polynomial function. 10 power x is a exponential function. Okay, so the way we differentiate 10 power x is different than the way we differentiate x power 10.
10.
Okay, x power 10 is 10x power 9. That is
Yes.
fine. But 10 power x is not x 10 power x minus 1. Okay,
Yes,
ma?
sir.
So what
Understood.
is that? 10 power x, 10 power x, ln 10.
Yes, sir.
A power x, ln 10. So how do we get this? We take logarithms on both sides and differentiate both sides and then express y dash in terms of y. Okay, ma?
Yes, sir.
Okay.
Sir?
Can you see my screen?
Yes, sir.
Okay, 50. 10 power now, 10 power mod x minus 1 by x. Okay, there is an x. Okay, so now how does 10 power x look? 10 power x is an exponential function. It looks like this. Agreed?
Yes, sir.
This also I'm removing. 10 power x is an exponential function. Basically, 10 power x minus 1 means you are shifting the graph little downwards. Agreed?
Yes, sir.
So 10 power x minus 1 x minus 1 means the graph is shifted 1 unit downwards. It is becoming like this. This by x. What is x? X is our straight line. Okay.
Yes, sir.
What we are doing, this by this we are doing. Okay. Then we are getting this h. What is this h? Okay. We are getting this. When this is positive, this is positive. When this is negative, this is negative. That's why the graph is continuous like this. Okay.
Okay. Mm.
Okay. Now this is your 10 power x. What happens if you do 10 power mod x? Okay. 10 power mod x. This is becoming like this. Okay.
Mm.
What is
Yes, sir.
why is this happening?
It's a step function, right? So it will
It
break
is
it.
not step function. It is absolute function. Okay. 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 Cool. So
Okay.
10 power x is this. Okay.
Yes, sir.
10 power x is this. What is 10 power minus x? 10 power minus x. This is f of x versus f of minus x. Okay.
Mm.
We discussed 10 power x is this. F of minus x is just a reflection with respect to y axis. Agreed?
Right. Yes.
The blue line is 10 power minus x. Agreed?
Yes.
Okay. Now 10 power mod x means it is equal to 10 power x when x greater than 0 and equal to 10 power minus x when x less than 0. Agreed?
Yes,
And
sir.
x greater than 0 mod x is x. Right? So x greater than 0, we take this part of the graph. Okay?
Okay.
The red part. When x less than 0, what is happening? This becomes 10 power minus x. Right?
Mm. Yes.
Agreed. So that's why we are taking this part of the graph. Okay,
Okay.
when x is less than 0. Understood? So
Yes, sir.
that's why net we are getting this graph 10 power mod x.
Mm.
Agreed?
Yes, sir.
10 power mod x is this. Now if you do the same thing now, okay, 10 power mod x
Minus 1 by x.
minus 1, this is becoming like this. Okay, that is you're convinced, no? This part
Yes.
is becoming 1 down. Okay, the
Yes,
graph
sir.
is shifting 1 unit down, whole by what is this? By
X.
x. Okay, by x. Now what is happening? This graph is shifting down, but still it is positive. Okay, it is still always positive. Now,
Mm.
earlier what is happening? Positive by positive, negative by negative. Right now, what has happened? Positive by positive and positive by negative. That's why there is this break. Understood?
Okay.
Okay,
So it is discontinuous.
it is discontinuous. Okay, earlier also the function is not defined at 0, but the point is this is not removable discontinuity. It's not just a whole.
Mm.
Okay. Okay. Earlier, here also it was not defined. At x equals to 0, the function is still not defined, right? You cannot
Yes.
directly substitute. But still, you can define the value of the function. Understood? That's the important thing here. You can
Okay.
define to a certain point to make it continuous. But in this case, you can't even do that. Understood?
Right.
Okay. So basically, this one again, this is actually an odd function. Okay.
Right.
Understood? No?
Yes.
Okay. So now coming back to our problem. Okay. So now we have discussed these ones, no?
Yes.
49, 50, 51, 52. See, sin x by x is saying it will be continuous from the left, continuous from the right, but it cannot be extended to be continuous. Agreed?
Yes.
Okay. Then 49, 50, 1 plus 2x. Okay. So we discussed that it is actually e square. Okay. This is actually equal to e square and you can fill the hole. Okay. That's what he's saying. Agreed, ma?
Yes.
Okay. Now this one he's saying it will be continuous from the right and the left, but there is a break. Okay.
Hmm.
So it cannot be extended.
Okay.
Okay. It cannot be extended. Okay. So if we f of 0 equals to 2.3, what that means, it is continuous from the right. If we define it as minus 2.3, then it will be continuous from the left. But the function cannot be extended. Okay, ma?
Yes.
You understood the difference, no? Between this kind of function, and this. Here you
Yes.
cannot extend the continuity. In this case, you can extend. Here you can extend. Here you cannot extend the continuity. Okay?
Okay.
Okay, so this is an important topic. Okay, uh, removable discontinuity also we discussed. Okay,
Hmm.
now, okay, this is about asymptotes. Okay,
Okay.
one thing, today night I will be traveling. Okay,
Okay, sir.
so tomorrow morning I will not be taking class.
Okay,
Okay,
sir.
so tomorrow evening will it be fine? Mostly I will be reaching home by night. So tomorrow evening, if you want, tomorrow evening we can do.
Fine, sir. Sure,
Is
sir.
it fine? Okay,
No, you
tomorrow.
can just ping my dad at what time. He'll let me know.
Okay. Okay. Mostly you will be okay at 9 o'clock or something,
Yes, sir.
8 or 9 or something.
I'm
Okay,
fine.
mostly around that time I will be reaching home back by then, and after that we'll continue the morning class. Okay, ma?
Okay. Okay, sir.
Okay. So you continue doing this